In this video, we'll be solving a modified version of problem 5.2.1 from Broverman. We'll be doing two new things. We'll be finding both the time-weighted and dollar-weighted, also known as money-weighted, rates of return for a fund. But before we look at the problem, I should say something about the naming here. One of these makes a lot of sense as far as its name goes, and one doesn't make much sense. Dollar-weighted, also known as money-weighted, makes a lot of sense. For that kind of rate of return, we are definitely going to be taking into account the cash flows, both in and out of the account, and weighting them essentially by their size and when they occur. However, the naming for the time-weighted rate of return, well, it doesn't make much sense. You might call it a misnomer. It's really misnamed, in my opinion, and I've found some other people who agreed with me online. You're in fact explicitly not taking time into account other than just realizing you're going to compute it over a year or maybe over 2 years, or maybe you're going to annualize it over 2 years. You're not taking into account when the deposits and withdrawals are occurring. So calling it time-weighted really doesn't make a ton of sense, but it's what we're stuck with. It can be confusing that way. So just realize if there's a reason you're confused, it makes a lot of sense that you're confused. But we need to stick with the name that we are given. Here are the details regarding the fund value, contributions and withdrawals, and also balances that you see right here in this table. There are two parts to this problem, although it's only the first part, and in fact only the last part of part A here, that is in the actual problem from Broverman 5.2.1. The rest of it is something I made up. That's how this problem is modified. In part A, we'll be finding the effective annual time-weighted return for three things: for 2015 as a single year, for 2016 as a single year, and for the 2-year period from 2015 to 2016. There will be an overall percentage growth over that 2-year period, but we will then find the corresponding effective annual growth for that. Part B, which again is not in the book, we'll be finding the dollar-weighted or money-weighted rate of return for 2 individual years, and we will not be annualizing it over the entire 2-year period for 2015 and for 2016 individually. All right, let's make a timeline. I'm going to label the timeline, well, first of all, to be in years, so 0.5 is going to represent half a year, which makes sense if you look at the table. By the way, if you're not used to the way Americans write dates, 7/1/15 really means the 1st of July 2015. That would be how many people in the world would write that as a 1/7/15. Okay, so if you're not from America, just realize that means July 1st, 1st of July 2015. So you see these occurrences for the inflows and outflows are essentially at half years. The contributions are flowing into the fund and the benefits are coming back out half years and at the end of the year. So it makes sense to label the timeline this way. But as far as how I label the money values here, I'm going to do it differently than usual. Let me first, across the bottom here, label the balances that we see here. So we've got a million balance at time 0. Let's say these money amounts are in thousands, so I won't actually write a million. I'll write 1,000, since a million is 1,000 thousands. And then we'll put the balance of 1,310,000 or 1310,000 at time 0.5. Now that's occurring on July 1st, 1st of July 2015, right after that contribution on, this would be June 30th, 30th of June 2015. So just keep that in mind. Both of these are essentially at the same time, even though we're dating them differently. Then we have the balance of this thing, 1265 at time 1, 1540 at time 1.5, and finally 1420 at time 2. But to get to these values, two things are occurring. Interest is being earned, or maybe the fund is losing value, and you're also having the contributions going into the fund and benefits coming out of the fund. You see it's a contribution here on July 30th. These contributions are occurring at 0.5 and 1.5, whereas the benefits are being paid at 1 and 2, looking at these dates. Contribution of 250,000. That means whatever this fund grows to from time 0 to time 0.5, if I add 250,000 to that, I'm going to get this 1310. And that means to find out what the fund grew to, by this time, I need to subtract. 1310 minus 250 would be 1060. These are in thousands again. Okay, so the growth there from time 0 to 0.5 is a 6% growth over a half a year, 1,000 to 1,060. At time 1, there's no contributions, there's only benefits paid, money taken out of the fund. So to get to this 1,265, I need to subtract 150 from whatever the balance is here right before I have the benefit withdrawal. So this 1310 is going to grow to that amount. So to figure out what goes up there, I need to add. 1265 plus 150 would be 1415. So it's growing from 1310 to 1415 over that second half of the first year. I have again the contribution of 250,000 at time 1.5. Doing a subtraction to figure out what goes here, 1540 minus 250, that's going to be 1290. So the account grows from 1265 to 1290 before that contribution. And finally, at the end, a benefit of 150,000 is paid. So to figure out the balance right before that benefit is paid, I'd add 1420 plus 150 is going to be 1570. The account grows from 1540 to 1570. So here you can see right away the performance over the first year seems to be better than the performance over the second year. Now, as far as the time-weighted rates of return here, we are just focused on the growth, essentially. We are ignoring the actual amount of the contributions and benefits, contributions into the fund and benefits paid out of the fund. I mean, they are, of course, relevant for determining these amounts, but we are just focused on the growth. And so for the time-weighted return for 2015, we do just focus on that growth. Again, it's 6% growth for the first half year. I could write that as a growth factor of 1,060 over 1,000, which of course will be 1.06, representing 6% growth. And then for the second half of the first year, it grew from 1310 to 1415. 1415 divided by 1310 is going to be the growth factor for the second half of the year. Let's go ahead and find that. 1415 divided by 1310 is approximately, whoops, mistake, 1415 divided by 1310 is about 1.08015. Let's go ahead and, as I usually do, carry all those decimal places, 0.15267, about 8.015% growth. And effectively, by multiplying these two things, you are finding the growth factor over the entire year. Multiply that times 1.06, it's about 14.5% growth over the entire year. And that is what the time-weighted return for 2015 is going to be. Subtract 1 from this, and you're going to get this 0.14496,183. 0.14496,183, approximately 14.496%. All right, so that's the time-weighted return for 2015. It's already an annual thing because 2015 is a single year. How about the time-weighted return for 2016? And by the way, as far as the naming goes, calling this a time-weighted return, the calculation, again, that's a misnomer. The calculation would be the exact same calculation even if this 0.5 was something different, even if the contribution of this 250 occurred at some other moment in time and these balances were correct. And so because of that, really time is not being weighted, okay? But we still call it a time-weighted rate of return. For 2016, it's going to be smaller. The percent growth factor for the first half of the second year is going to be 1290 divided by 1265. And for the second half of the second year, it's going to be 1570 divided by 1540. And then I'm going to subtract 1. Okay, so again, this is a new kind of calculation. We haven't done this kind of calculation before, but this is what a time-weighted return calculation looks like. Let's go ahead and do that. 1290 divided by 1265. That's about 1.01976 285, about 1.976% growth. Instead of writing all those out, I'll just store this in register 1. Then 1570 divided by 1540 is also not very much growth. This is 1.01948, about 1.95% growth, a little bit smaller yet. Multiply those two things, multiply this times what's in register 1. You get about 3.96% growth for the second year. Subtract 1 to officially find that. We get about 0.03962836, about 3.963% growth as the time-weighted return for 2016. Those are already annual, as they are. But now I want to look at the 2-year period, and again, this is the part that you're actually supposed to do in the problem as it's actually described in Broverman, is to find the effective annual time rate of return for the 2-year period. To do that, we first find the time rate of return itself for that 2-year period as a 2-year effective growth. And we do the same kind of thing. We figure out the percent rate of growth over each period when we're between these contributions and benefit payments, and subtract 1, find those growth factors, multiply them, subtract 1, but then we will convert that to an annualized rate in the usual kind of way, actually, at the end. So the time-weighted return for 2015 and 2016 combined is going to be the product of this with this with this with this, then minus 1. I'll go ahead and write it out. 1060 over 1000 times 1415 over 1310 times 1290 over 1265 times 1570 over 1540. Product of those four numbers minus 1. Let's not write all those out. Let's just do some storing in the calculator here. I know what that is already, so let's do this one first. 1415 divide by 1310, store that in register 1. 1290 divide by 1265, store that in register 2. 1570 divide by 1540. I'll just go ahead and multiply by what's in register 2 times what's in register 1 times 1.06. I get 1.19033479, subtract 1. So for the combined 2-year period, the growth, the performance, so to speak, that you judge the manager by of this fund is going to be 0.190333479, about 19.03%. But to convert this to a corresponding effective annual rate, where we say, call it I, is the effective annual time-weighted return, we convert it in the usual way. You would want 1 plus I squared to be this thing plus 1. That'd be 1.190333479. So you're going to need to take the square root and then subtract 1. I is going to be the square root of 1.190333479. That's a 0 there, and then minus 1. So add 1 to this, take the square root, subtract 1. The answer to the question in Broverman is about 9.102%. Okay? So that's part A, and again, it's only the last part that's the actual question in Broverman. All right, part B. Now we're on to the dollar-weighted or money-weighted rate of return for 2015 and 2016 as in individual years. You might wonder why I'm not doing it over the 2-year period. Well, if I were to do it over the 2-year period, I'd really be finding the internal rate of return in the usual way, what we've done recently. using compound interest. The emphasis, at least in Broverman's book, The Mathematics of Investment and Credit, which people use to study for actuarial exam 2, is that these things are best thought of, especially this dollar-weighted or money-weighted rate of return, in the way that I'm going to show you over just a single year. Because what we're going to do is we're going to use simple interest instead of compound interest in this context. And, over a year, simple interest and compound interest are not that different from each other. You got a good linear approximation to the compound interest with simple interest over 1 year. And the benefit of simple interest is that it's easier to solve. It's easier to solve for the unknown rate of return. You get a linear equation in I that's relatively easy to solve. You don't need fancy calculator features to solve for it. So that's what we'll do now. So this was part A up here. Part B down here is what we're about to do. So it's essentially a present value equation, or a future value equation is the way we're going to think of it actually. We're going to take all these amounts over each single year based on the contributions and withdrawals and the starting balance, and promote them in time, say to 1 year, to the end of that year. So I'm separating it into 2 different years here, and set it equal to the future value, the final balance at the end. So for 2015, we got an inflow into the fund, say, of 1,000 thousands, which again is a million, but I'll write it as 1,000. To promote that forward in time to the end of the year, I just multiply by 1 plus I, where I is this annual dollar-weighted or money-weighted rate of return that I'm going to solve for. Now that would be the case whether I was thinking about compound interest or simple interest, but for the next amount, which is really this contribution into the fund of 250,000 at time 0.5, June 30th of 2015, that gets promoted in time forward by a half a year. And again, I use simple interest now, not compound interest. I write this as 250 times 1 plus 1/2 I for the half a year remaining after that deposit. And here I am taking the time that this occurs explicitly into account, unlike the time-weighted rate of return. Yet another reason why the time-weighted rate of return is kind of a misnomer. Then I have the benefit paid, 150,000 at, this is December 31st, 2015, right at the end of the year. That's already at the end of the year. It does not need to go forward in time any amount. I'll just write a minus 150 here. And that has to equal the final balance at the end of the first year, which is given as the balance on January 1st, 2016 of 1265. So this is the equation of value to solve for I to give us the dollar-weighted or money-weighted rate of return for 2015. It's a linear equation in I. We can pretty quickly solve it here. We got 1,000 times 1 and 250 times 1 is 1,250. We've got 1,000 times I and 250 times a half I. That'll be 1,125 I. Minus, well, okay, that's already add the 150 to both sides. On this side, then that's going to give us a 1,415. Subtract 1,250 from both sides, we'll get 1,125 I equals, what will it be here, 165 it looks like. Let me double check that here. Yep, 165. So I, which is going to be the dollar-weighted or money-weighted rate of return for 2015, will be 165 divided by 1,125. $165 divided by 1125 comes out to about 14.7%. 14.67%. Not too far away from this one. They're relatively close for this one. What about for the next one? For 2016, the balance at the start of 2016 is 1265. We got a contribution of 250 at time 0.5 for that second year. A withdrawal of 150 at the end of that second year, and a final balance of 1420. So a similar kind of equation. 1265 times 1 plus I plus 250 times 1 plus 1/2 I minus 150 gives the final balance of, again, 1420. So let's see, 1265 plus 250, that's going to be 1515. And then we have 1265 plus times I plus 250 times 1/2 I. 1265 plus 125 is going to be, what, 1390 I. And then 150 plus 1420 is going to be 1570. So that'll give 1390 I equals 1570 minus 1515, which will be 55. So I is 55 over 1390. 55 over 1390. It's about 0.03957. 0.03957, about 3.957%. And once again, comparing this with the time-weighted return for 2016, you can see these are pretty comparable. Okay, I think these were comparable partially because this was occurring at halfway through each year, but definitely they're not always comparable. Generally speaking, from what I've seen and looking online, when account managers are being evaluated, it's typically the time-weighted return that takes more precedence. Excuse me here while I log in. My computer logged me out. It's the time-weighted return that takes more precedence because you're not taking into account the actual amounts of the contributions and benefits, which are often beyond the manager's control. So they're comparable here, but in general they could be pretty different. And this is something to know for actuarial exam 2.